Hello everyone, I am Dr. Anil Shirahatti, professor and consultant. So we start with today's session, that is session 2 on module 4 of management and economics. So in the last class we saw uh, the basis of present worth and solved one simple problem. So in today's class we will be solving two problems. Okay. So let's start with the problem part. So what the problem says, an investor can make 3 end of years payment of rupees 15,000 which are expected to generate a receipt of rupees 10,000 at the end of year 4, which will increase annually by 2,500 for the following 5 years. Is this investment an attractive or not? Assuming I is equal to 10%. So what it means is, a person is planning to invest or planning to deposit rupees 15,000 for 3 years. Okay. So and at the end of the 3 years he will stop doing payment. Then at the end of 4th year, okay, he will start receiving rupees 10,000, okay, which will increase every year by 2,500 for the next 5 years. Okay, so what is the total amount of years? It is around 8. Okay, now how to draw this cash flow? So what it was said, he has to, an investor make an 3 end of year payments. So you see this word 3 end of year payments. So payments are then done of rupees 15,000 at the end of every year only for 3 years. So when the end of first year happens, so 0 to 1, so here will be the first payment, then second payment, then third payment. And what about that payment amount? It is rupees 15,000 each. So every year he has made a payment of rupees 15,000 at the end of every year. So at the end of first year 15,000, at the end of second year 15, at the end of third year 15,000. So total each year he has made a 15,000 payment. Now at the end of the fourth year, when it is finishing, he is getting some amount, which amount is around 10,000 for first year. Second year, again next year it will increases by 2,500. So here he may get 12,500. Third he may get 15,000, then 17,500 and 20,000. Now this is a gradient series, increasing gradient. So every year, so that's why it is denoted by A dash equal to 10,000, and this gradient is 2,500. So see, from here 5 payments he is making. Okay, now we want to solve this problem. So what is the first method? We have a rate of interest is 10%. We have to first move everything to present worth. So we have to move this series, that is which is happening for first 3 years, to the 0 position, and let's say we are finding individually the present worth. The present worth is, let's say, PW1. Now there is a second series, that is PW2. Now this has to be come to again 1, and that, let's say, represent this one as PW2. So what will be the net present worth? Nothing but whatever the present worth of the receipts, that is the income, minus the expenditure. Okay, now this can be written in a single way, but I want to solve this one individually to show you the complications in these problems. Okay, so let's start with the first one. It is a very easy one. Okay, simple. First 3 years I am having an investment of 15,000. Okay, and I want to move to this one. So the relation is between P and A. Okay, so I can write this a simple equation as now here why I am not putting plus and minus is because I am solving it individually. Okay, then plus and minus will be taken at the end, whether it should be a positive or negative. So that's why is equal to sign is done. Okay, so here A is known to me, P by A, I comma N. Now what is the I? I is 10% and N is 3 years. Okay, so N is 3 years, not the 8 years. Okay, so 2.48, and if I substitute this one, I get a value of around 37,305. Now let's go to the, this was very simple one. Now let's go to the second part where income is coming. Now income is coming, or the amount he is getting is rupees 10,000 at the end of fourth year, and then it is increasing by 2,500 each. Now this series cannot be moved directly here because here is a complete blank, nothing is happening in this series. So what is the alternative? If I have to find the present worth, I have to take into steps. First is I have to move this one at third position, or one more option is I can move it here also, or I can move it at the end also, and then move again back to the 0 position. So when I do this one, let's say I have found F. Intentionally I am showing a F because with respect to present worth this is happening somewhere in the future. Okay, so I will move this one to F. Okay, and then from this one I can easily, because this is a single payment, there is a relation between F and P, and I can directly find it, move it to 0 position. Okay, now let's solve. Whenever I am solving this one, you see this, when I am solving trying to move this series to this F position, then this number of years will change. So this will become my present worth for temporary present worth, and from here I have to see number of years: 1 year, 2 year, 3 year, 4 year, and 5 years. Okay, now what is this relation? This is the relation between F and P and A. Even I am showing a symbol of F, this is actually a P only. Okay, present worth. So there is a relationship between P and A. Okay, so now as the relationship is between P and A, okay, why P and A? Because I am considering this as my present worth now. Okay, so let's start to solve this one. Now this we don't have anything like a gradient type relationship between P and A, so this has to be converted into A first. So how to convert that one? There is a simple equation to convert this into a single annuity, that is A dash plus G into A by G I comma N. Why this plus sign? Because this is in positive direction. Okay, so there is a positive increase is there, so that's why it is coming plus. If I substitute that one, that is around, first is 10,000 plus 2,500, A by G 10%, and how many years this is happening? This is happening 1 2 3 4 5 till 5 years, so that's why it is 5. And if I substitute this constant value, I can find a value of A which is around 14,525. What it means is, now this series, whatever you are seeing increasing series, is converted into a constant annual series where annual value is around 14,525. Okay, so this whatever increasing series is converted into a constant annual series of 14,525. Now we have a clear relationship. A is known to us and we have to find the value for P. So how to do that one? This is the, I have to move this one to third. Okay, now it is from 0 to 5. So what is the, now here the relationship is between P and A. Okay, so simple A, okay, into P by A I comma N. What is the value for I? 10%. N is 5 years. Okay, so N is 5 years. So if I substitute this one, I will get a value of around 55,064.28. Now why interest? Actually this is a P only. Okay, at third position, but when I am doing with respect to 0, this P is converted into F, because this F, it is a future value. Okay, now what I have done till now, I have converted this one, the gradient series, to a first annuity series, and then I have able to find a future value F which is around 55,000, and that value I have to move to this 0th position. So this value I got around 55,000 something, I got it. Okay, so this I have to move to the present value. So that is the relationship between P and F, and in which F is known to me, that is around 55,000, and this P I have to find. Okay, so that is 55,000 P by F. I now here you can see I am moving from the third year to the first year. Okay, so that's why it is 3, and if I substitute this one, I'll get a value of around 41,369. Now you can see there is a whatever the income is coming around 41,000, and what was the expenditure? Expenditure was this A series moved to the this one. So this is the income, this is the expenditure. Okay, so that's why in initial part I have not taken the plus and minus sign. So you can see in the present worth receipts are PW2 minus PW1. Now if you are writing this one in a single stroke, then you can use the sign, otherwise you cannot, you can neglect the signs. Okay, so what was this present value? That is around 41,369, and what was the investment? Around 37,030. So the net present worth is around 4064. That and also it is in positive. So that means a person will have profit, and he should definitely go ahead with the investment. Okay, since the net present worth is positive, the investment is an attractive one. So this is a single series. Okay, so you saw how a series is not directly starting from 1, it may be starting in between, and then again you have to move to this 0 position. So this problem will demonstrate the situation where only the cash flow is happening at some specific time, and it has to maybe move to. So let's start with the problem. So what the problem says, a company is planning to buy a new milling machine. It has three options of machines: machine A, machine B, machine C, from three different suppliers. Okay, the initial investment, salvage values, life of the machine, annual maintenance, revenue, all are given in detail in the table. We have to use present worth comparison method and suggest which option or which machine is the best, and the rate of interest is given as 12%. So if I see the table, what it says, the first machine, okay, has an initial investment of around 35 lakhs, then annual revenue of around 8 lakhs, which is constant, again annual constant maintenance of around 1 lakh, and at the end of the life, that is 10 years, the machine have a scrap value or salvage value of around 5 lakh. The life of all the three machines are same, but in case of a second machine, the initial investment is around 37.5 lakhs. Then annual revenue for first year is 8 lakhs, but after that it is decreases by 2%. So that is 2% of 8 lakhs, it's around 16,000 rupees. Then there is the annual maintenance cost, which is remaining constant, which is around 1.15 lakhs, and then there is a salvage value of 5 lakh 50,000. In case of a machine 3, there is an initial investment of 35.5 lakhs. Then annual maintenance is annual revenue is remaining constant, which is 8 lakhs. But in case of annual maintenance, first year it is only 80,000, and thereafter it is increasing by rupees 8,000. And the salvage value is 7 lakhs. And if you see, the life is also 10 years. So when like this situation comes, we have to use the comparison method and decide which will give me the best alternative. So let's start solve this one by one. So let's go to the first machine, that is machine A. So I have drawn in the cash flow diagram as per the instruction. First we have to draw a straight line and decide the periods. So periods are from 0 to 10 years. So let's start one by one. So first is initial investment of 35 lakhs. So the money is going out of the pocket, so that's why you can see here initial investment of 35 lakhs. Okay, it is coming at the zero. So before starting the business, I have to invest 35 lakhs, and then only the revenue will start coming into. Then annual maintenance, every year I have to pay 1 lakh rupees as the annual, and it is a constant over the years. Then at end of first year, I will get a revenue of around 8 lakhs, and which is remaining constant till 10 years. So this is the cash flow, and the rate of interest given is and at the end of 10th year, again there is a salvage value of 5 lakh. So this is the total cash flow diagram for machine A. the rate of interest is 12%, and I have to find the present worth of this series. So let's start and find the present worth of the series. So if you see here, so let's start one by one. Let I am denoting it by PWA. So let's start the first parameter, the present worth. Let's start all negative first. So what are the investment? 35 lakhs. It is already at 0th position, that's why minus P. Now here annual, I have just denoted by A2 because there are two annual series. So this is the relationship again is between P and A, where A is known to me and I have to find P. So A into P by A into I comma N. I is in this case 12%, N is 10 years, and this constant can be found using your compound tables. Now there is no other uh, expenditure. I have to go to the revenue sides. So first year revenue is constant, it is around 8 lakh rupees, and the relationship again is between P and A. So that's why A, that is A1, P by A, I comma N. Then there is a salvage value at the end of this term, that is 10 years, and that's as this is happening in future, there is a relationship between P and F value. Okay, and in which F is known to me, I have to find the value for P by moving this one at 0th position. So what is the P value here? P is nothing but here S P by F I comma N. Here I is again 12%, but N is 10 years, because from 10th year I have to move to 0th year. So if I substitute these values, that is minus 35 lakhs minus 1 lakh into P by A, 12%, then N is 10%, then revenue 8 lakh, P by A 12%, comma 10, then 5 lakhs, P by F, that is a relation 12%, and N is the 10th year. So if I get this all this constant value from compound table, that values are around 5.65, 5 point, and 0.322. And once I substitute this one, the total present worth of the first series at the first machine I get is 6,16,000 rupees. Okay, so this is the present worth of machine A. Now let similar grounds I'll try to find the present worth of the second machine. Now in case of a second machine, there is an initial investment of around 37.5 lakhs. Then you can see annual revenue is decreasing. Okay, so first let's go to the maintenance side, that is 1.15 constant, not an issue. Now annual revenue is decreasing. Okay, so first year you can see there is an annual revenue of 8 lakhs and then it is decreasing. So 16,000 is nothing but 2% of 8 lakhs, 2% of 8 lakhs. Okay, that is around 16,000. So every year it is decreasing, and then at the end of this period I am getting a scrap value or salvage value of 5.5 lakhs, and I have to, have a rate of interest of 12%, and I need to find the present worth of this series. So let's start one by one. So all maintenance or expenditure first. So minus 37.5 lakhs, that is minus P. Then there is a relationship between P and A, that is A2, P by A, I comma N. Now if you see this series, now what I have to do is first this series has to be converted into a constant A value. Okay, so this series has to be converted into a constant A value. Okay, now that A I have to find first. Okay, so this is A, I have to do find, and then there will be a relationship between P and A. Now only A dash and G are known, so that's why you can see in this series the first part whatever I am showing you, that is A dash, that is A. Okay, that is equal to A dash minus G. Why minus G? Because it is a negative decreasing, minus G, A comma I, A comma G, I comma N. Now from this I will find A, and if I multiply that one by P by A, I comma N, I can get this series move to 0th position. And definitely S has to be moved to the 0th position. That is the relationship between P by F. Okay, so this is nothing but A, and if I substitute this all the data, I will get a value equal to minus 26,734. So you can see in this series the net value is negative. That means if I invest in this machine, I will have a loss of 26,000 rupees. Okay, let's go to the last machine, which is around a investment of minus 35 lakhs. Then annual revenue of 8 lakhs. Okay, it's constant. Then if you see in this series, annual maintenance is increasing at a rate of 8,000 rupees. So first year annual maintenance is 8,000. Next year it is increasing by 8,000. That this here it becomes 88k. Again another 8k. So next year it may become 96k. Okay. Why this series happens is because it says the first year maintenance machine is new. So I have only 80,000 maintenance. As the age of the machine goes, the maintenance cost is increased. At the end of the life, the salvage value is 7 lakh rupees, and if you see here, the rate of interest is 12%, and the present worth we have to find using our equations. So let's see the present worth of this one. Similar grounds, uh, A, this present worth already initial investment is 0, so minus P. Now the same series again it has to be converted into constant A value. Okay, so that is done at this position. Okay, the first part is whatever you are seeing. This part is the A what I am finding, converting this A dash gradient series into a constant annuity series, and then I will multiply with this second parameter. Okay, to get uh, the this series move to the zeroth position, and this will your regular stuff. So once I substitute all these values, that is minus 30.5 lakhs. Here if you see the series is increasing, so that's why you got a positive sign. Okay, 8 lakh 80,000 plus 8,000 into A by G 12 comma 10. Then again I am multiplying this multiplication. So whatever the value I got, this one, this is nothing but the constant A converted. Okay, and multiply this one with this factor, I'll get the relationship between P and A part. Fine. And once I substitute all the constant variables from the compound table, I got a value of around 5,81,358. So let's compare all the net present worth from all these three analysis. So we got for machine A around 6 lakhs 16,000. For machine B I got minus 26,734, and for machine C I got plus 5 lakh 81,000. So if I see from this series, machine B is having completely negative value. So that means there is a loss. So that's why this should not be considered itself. So first is wiped out. So machine B we are not considering because there is a loss of. Now machine A and machine C both are having a profit, but we have to consider the most profitable one. So from this present worth you can see the present worth of machine A is more, which is around 6.16 lakhs compared to the machine C, which is 5.81 lakhs. So definitely we have to go for the option A, that is the 6.16 lakhs option. So machine A is the most profitable alternative from all these three alternatives. Okay, so so today we have solved two problems with a simple. First was a simple problem where the series is happening at some time in the future, and then again we have to move to some specific zero value and then move to the actual present value. And then in the second option there are different variables available, like annual maintenance is changing or increasing or decreasing, annual sales is increasing or decreasing. We saw the three machines and then we decided, depends upon that present value, which one is the best option for among the three alternatives. So this is the end of this today's session. So if you have any questions, you can contact me on my mail ID or even you can text me. Thank you everyone.